Okie dokie. In this problem, I'll work out 3 more examples of 642A. If you need more of a breakdown on the general approach and process, feel free to check out the first video where I work out one example and go into it a little bit more depth. So for this one, first step is we're trying to match the bases of both sides. So if the left side already has a base of 5, there's probably not much else we can do with that. We're not going to rewrite that by any means. But if we can rewrite the 125 to have a base of 5, then we'd be in good hands. So again, if you're not familiar with a lot of different like powers and things, it might take some trial and error, and that's okay. Just play around in a calculator. Ask yourself 5 raised to what power would give us 125, because we are trying to replace 125 with 5 to some power so that this side's base matches this side's base, right? So anyway, the power would be 5 to the third. The power would be 3. So 5 cubed is replacing 125 because 5 cubed is equal to 125. And then we leave the exponent of 68 minus 4t. Now we have to distribute this 3. We treat it as we're multiplying the 3 times the 68 minus 4t. So we would get 5 to the 3 times 68. That's 180 plus 24. So that's 204. 204 minus 3 times 4 is 12t. And then we still have just 5 to the 2t plus 71 on the left side. Once we have the same base on both sides, we eliminate that base, and we're left with the 2 exponents equal to one another. So 2t plus 71 equals 204 minus 12t. All right, so let's combine the t terms. I'm going to add 12 to both sides, giving us 14t on the left, and then subtracting 71 on both sides to give us, 133. Think about that for a sec. Yeah, I think that's right. All right, so let's divide by 14 to get t by itself. I don't know if that's an answer. Probably not. This doesn't look great. I might have messed something up, I'll be honest. Unless somehow this divides. Does it divide by, it might divide by 7. That'd be crazy. Hold up. Let me find Desmos. All right, 133 over 14. All right, let's just divide it by 7. Oh, it does divide by 7. That's crazy. All right, so if we divide both the numerator and denominator by 7, we get, I think it was 19, and then 14 divided by 7 is 2. So 19 over 2, that's bonkers. Wow, you would never think. All right, learned something new today. 19 over 2 is our answer. Pretty good. All right, let's keep going. Let's not waste any time. So again, the approach, we want to match this base on the left with this base. Hopefully it's clear that we can rewrite the right side, the 81, as 9 squared. So we're matching the bases and making them both 9. But we cannot forget to have the exponent of negative t over 2 minus 20. So now we distribute the 2 here and here. So we get 9. 2 times negative t over 2 would just be negative t. And then 2 times negative 20 would be negative 40 or minus 40 equals 9 to the 2t minus 19. Once we have the same base, we cancel out the bases and we're left with 2t minus 19 equals negative t minus 40. We add t to both sides, getting 3t, and we add 19 to both sides, getting negative 21. Divide by 3, and we get t equals negative 7. Nice and quick one there. That's pretty much it. As I mentioned in the first video, if you don't prefer this process and you happen to just be doing the quiz where you have multiple choice answers, you can, of course, plug and chug these answer choices in the left and right sides and find which t value here makes the left equal to the right side. Does that make sense? So a little plug and chug action. Let's do one more. All right. So with this one, we see a 3. We're not going to reduce that 3 to a smaller base by any means, but we can reduce the 27 to have a base of 3, right? So we're going to leave 3 to the 91 over 2 minus t equals, and we're going to rewrite the 27 as 3 to the third power. And then that's still raised to the 3t plus 97 over 2. Lovely. All right, so now let's distribute the 3 here and here. Multiplying their exponents, we get 9t plus, now this is ugly, 3 times 90 is 270 plus 21, that's 291, yeah, over 2. So 3 times 97 is 291 plus 2. 291, and then it's over 2. Okay, just trying to make sure I have it right here. So we still have the left side, nothing's changed there. And now we have the same base on both sides. So we can eliminate the base, leaving us with the exponents. Now what can we do here? Let's add t to both sides, getting 10t on the right, and then I guess just subtract 291 over 2 from 91 over 2. So the 2's would kind of cancel. Let's not worry about that. So what would we have? Like, we wouldn't have to think about the 2's, I guess. So 91 minus 291, I think that's just negative 200. And then it's still over 2. So let's simplify that. That's negative 100. And that's equal to 10t, so we divide by 10. And we get negative 10 is equal to t. That's option B. We break out the eraser to see that B is our answer. So here was 3 more examples of this problem. I hope this made sense. I'll be honest, I feel like I've seen trickier problems in the past. Maybe they'll show up in the next video in the other problem types, like where rewriting the bases gets a little trickier. So, if you have any problems that pop up that aren't as, maybe weren't as easy as these ones, please let me know. I'm happy to work them out, send them my way, whatever. All right.